For most of human history, the earliest universe existed almost entirely in our imagination. Astronomers could calculate how the cosmos should have developed, but the first galaxies and ancient stellar systems were so distant that observing them directly was extremely difficult. Then the James Webb Space Telescope changed what was possible. Because Webb observes primarily in infrared wavelengths, it can investigate extremely distant objects whose light has traveled across billions of years of cosmic history. Among the remarkable objects revealed through this capability is a distant galaxy sometimes referred to as the spark galaxy. The galaxy itself is incredibly far away, but something surrounding it makes the observation especially valuable. Astronomers identified several compact sources of light around the galaxy that appear consistent with ancient globular clusters. Globular clusters are dense collections of stars held together by gravity. Some contain hundreds of thousands of stars, while others can contain even more. They are among the oldest stellar systems known. Our own Milky Way contains globular clusters that formed billions of years ago, making these objects valuable records of the conditions that existed during the early stages of galaxy formation. Now imagine seeing similar structures when the universe itself was much younger. The light-reaching Webb today began its journey billions of years ago. We are therefore not seeing these stellar systems as they would appear now. We are seeing an ancient version of them. That makes the observation more than a distant photograph. It is effectively a glimpse into cosmic history. Before Webb, extremely distant star clusters were often too faint and compact to study in detail. They could appear as little more than tiny points of light. Webb's infrared sensitivity and advanced imaging capabilities provide a much better opportunity to investigate their properties. Scientists can examine the brightness and colors of these distant sources and study information contained within their light. This helps researchers investigate how early galaxies built their stellar populations. The compact sources associated with the spark galaxy are particularly interesting because they appear to represent developed stellar systems that existed surprisingly early in cosmic history. Instead of only studying ancient clusters long after their formation, astronomers can observe them much closer to the era when they were originally assembled. It is similar to finding a historical civilization while its structures are still being constructed rather than discovering only its ruins much later. But there is another reason this observation was possible. The spark galaxy is affected by one of the most remarkable phenomena predicted by modern physics, gravitational lensing. According to Einstein's theory of general relativity, massive concentrations of matter can bend spacetime. When light from a distant object passes through that distorted region, its path can curve. If a massive galaxy cluster happens to lie between Earth and a much more distant galaxy, the cluster can act like a natural cosmic lens. The effect can magnify and stretch the distant object's light. That is what makes gravitational lensing so useful. A telescope does not need to become physically closer to the distant galaxy. Nature itself provides a magnifying effect. In this case, the galaxy cluster identified in the observation helped amplify the light from the distant spark galaxy. The unusual stretched appearance is therefore connected to the bending of light by gravity. Without this natural lensing effect, some of the tiny stellar systems surrounding the distant galaxy could have been much harder to detect. And that gives astronomers an extraordinary opportunity. By studying these ancient clusters, researchers can investigate how early galaxies formed stars, how quickly stellar systems developed, and what conditions existed during an important stage of cosmic evolution. The observation is not simply about one distant galaxy. It is another piece of evidence helping scientists reconstruct how the young universe gradually transformed into the complex cosmos we see today. And the deeper Webb looks, the further back in cosmic history we can observe. The real importance of the spark galaxy observation becomes clearer when we consider what astronomers are trying to understand. The early universe was not immediately filled with mature galaxies, stars, planets, and complex structures. It went through a long process of transformation. Matter gathered under gravity. Stars formed. Those stars changed their surroundings. Galaxies assembled. And over enormous periods of time, the universe developed into the structure we observe today. Ancient globular clusters can help scientists investigate this process. Because these stellar systems contain enormous populations of stars that formed early in cosmic history, they preserve clues about the environments in which galaxies were developing. Their ages, compositions, and physical characteristics can reveal information about the conditions that existed when the universe was much younger. This is where the James Webb Space Telescope becomes especially powerful. Rather than relying only on theoretical predictions, astronomers can now compare those models with observations of distant objects from the actual early universe. Every photon arriving at Webb carries information from a much earlier period. The light may have traveled for billions of years before reaching the telescope's mirrors. In that sense, astronomy allows us to look backward through time. When Webb observes an extremely distant galaxy or star cluster, it is seeing that object as it existed long ago. The object may have changed dramatically since then. It may have merged with other galaxies. Its stars may have evolved. Its structure may have been transformed. But the ancient light still carries a record of what that system looked like during that earlier era. That makes observations such as the Spark galaxy especially valuable. The compact stellar systems surrounding it provide researchers with another opportunity to study how large populations of stars came together in the early cosmos. Scientists can investigate questions such as how quickly these clusters formed, how efficiently early galaxies produced stars, and what physical conditions existed during those early stages. These clusters may also contain chemical information connected to earlier generations of stars. The first stars changed the young universe by producing and distributing heavier elements through their evolution and eventual deaths. Those elements later became part of new stars, planets, and other cosmic structures. In this way, the story of ancient star clusters is connected to the larger history of cosmic evolution. The universe we see today was built through generations of change. The stars around us are part of that long process. The planets, galaxies, and complex environments we observe did not appear instantly. They emerged from earlier generations of matter and stars. Webb is helping scientists investigate those early stages directly. That represents a major change in astronomy. For much of scientific history, researchers studied the present universe and then used physics and mathematical models to reconstruct its past. Now, powerful observatories can actually observe objects from billions of years ago. The past is arriving as light. And that light allows scientists to test ideas about how the universe evolved. But this is not the end of the investigation. The ancient stellar systems observed around distant galaxies are only part of a much larger population waiting to be studied. As Webb continues examining deeper regions of space, astronomers may discover additional ancient galaxies and star clusters. Future observatories could push these observations even farther, providing new information about the earliest stages of galaxy formation. Each discovery will add another piece to the cosmic timeline. We may learn more about when the first major stellar systems formed, how early galaxies grew, and how the young universe developed the structures that eventually became the modern cosmos. The Spark galaxy and its surrounding clusters therefore represent more than distant points of light. They are fragments of an ancient story. A story written billions of years ago and carried across space until it finally reached Earth. For humanity, this is one of the most extraordinary abilities science has ever developed. We cannot travel back billions of years. But we can collect the light that has traveled across those billions of years to reach us. James Webb gives us the tools to read that ancient light. And with every new observation, the early universe becomes a little less mysterious. There are still countless questions waiting to be answered. But one thing is becoming increasingly clear. The deeper we look into space, the further back we travel into